this video we will talk about the chi-square test. Listen, we use different statistical test, right? We use ANOVA test, we use chi-square test, we use t-test, we use z-test. Now these statistical tests that we use for the hypothesis testing test, these statistical tests are depends on the data. These statistical tests depends on the data, what type of data we are using, and what type of data we are using. If we are using the continuous data, we use the ANOVA, we use the t-test, we use z-test, right? These kind of tests we use for the continuous variable. What if we have the categorical variable like this: gender, male, female, right, in occupation, right, and the types of cancer, colorectal cancer, prostate cancer, breast cancer. If we have this kind of data, what test we used, right? Because continuous variables like this, we use ANOVA test, we use t-test, we use z-test. What if we have this kind of categorical data set? When we have this kind of categorical data set, and we are making the claims and we are doing the hypothesis test, we will use the chi-square test. Yes, chi-square test basically used to test the relationship between the categorical variables like this. Basically there are two applications of the chi-square test. One is the test of independence, one is the test of independence, right? This is the one of the application of the using the chi-square. What does it mean by the test of independence? Test of independence means if we have two variables, if we have the two categorical variables, and we want to see either there is a dependent on each other or not, or I can say either there is a relationship between these two categorical variable or not. For that thing we use the test of independence to check either there is a relation or not, right? This is the one of the application to using the chi-square test. The second is goodness of fit. Goodness of fit. What is the goodness of fit? Goodness of fit says if you are using this sample, right, and if you want to check either this sample belong to the population distribution or not, right? If you are whatever the sample we are working on, either they belong to does it belong to the population or not. For that thing we also use the goodness of fit. That is the goodness of fit. Fit means how sample fits in the population distribution. That is why they know the goodness of it, how well the sample fit in the population distribution. And there are the two applications of the chi-square test. One is the test of independence and the second is the goodness of fit. But most of the cases we use in a data science or in statistics to test the dependency of the variables on each other, either there is a relation or not. Here we will discuss this example, the test of independence, right? Let's suppose there is a assumption, there is a null hypothesis that there is no relationship between these two variables, which is the gender or occupation. What does it mean by a relationship? Means either there is a particular kind of a category like this, male, either the proportion of the male in a freelancer as a freelancer is high or not, right? Either the female proportion as the occupation in an artist, either there is a high proportion of the female in an artist occupation compared to the male or not. This kind of relationship if you want to check, we use the chi-square test. So here we are using the same example, either there is a relationship between these two variable, which is the gender and occupation, or not, right? So how do we do this? There is a null hypothesis which is saying there is no relationship between these two variables. The null alternative hypothesis saying there is a relationship between these two variables. Okay. And then we'll set the significance level. We'll set the significance level alpha, which is alpha. Mostly we use the 0.05, right? And then we will calculate the statistics test, right? When we calculate the statistics test, which is the chi-square test, which is denoted by this symbol, and then with the help of the chi-square we will calculate the p-value. If the p-value is greater than alpha, we will say that there is no relationship between these two categorical variable. If the p-value is less than alpha, we reject the null hypothesis, and we will able to say that there is a relationship between these two variables. Now how we will calculate this statistics test, right? Let's suppose we have a data set, right? We have a data set, and we will make the contingency table, right? We will make the contingency table to calculate the expected frequency with the help of observed frequency, right? Now what is the observed frequency and what is the expected frequency? Listen, observed frequency is frequency. For example, if we do the experiment, right, whatever outcome we get, right, we measured, that is the outcome. For example, we are flipping the coin 5 times. We are flipping the coins, and whatever the times the head occurred after flipping the coin 5 times, we will measure how many times head comes. We will measure it. After measuring, we are able to say these are the observed data, right? These are the observed data. After doing the experiment, we measured. After measuring, we are able to say these are the observed data, right? This is the observed data. What is the frequency of expected frequency? Expected frequency or expected data is before doing the experiment. We expect on the basis of the probability theory that will be the outcome, right? The observed data, after the outcomes we get in the experiment, then we observe. In expected data, we expected some results before the experiment. That is the difference between the observed data and the frequency data. Here we are going to calculate that expected frequency, and with the help of frequency we will use this chi-square formula, which is saying the summation of observed frequency minus expected frequency. The FO means the observed frequency, and FE means expected frequency. We will square it and divide it by the expected frequency. We will get the chi-square, right? If the value is very high, the chi-square test means the difference is if the difference is high, then we will get the highest value. If we get the highest value, we are able to say that there is a relationship, right? So if the difference between the observed frequency and chi-square expected frequency is high, we will get the highest value. If there is the highest value, we are able to say there is a relationship between if the chi-square value is equal to 0, means that there is no relationship between these two variables, right? Now how we calculate the observed expected frequency? We will make the contingency table. Here we are able to say this. How we will calculate the expected frequency with the help of this formula. Expected frequency is the sum of rows values multiplied by sum of column values divided by total, right? Total. How I will calculate the expected frequency of this value? The total is 300, right? The total is 300. We will divide. This is the sum of rows 300, and this is the sum of columns. We'll multiply this sum of columns, sum of rows multiplied by sum of column divided by 500, and we'll get the expected frequency, which is in a green value, right? Similarly, we'll calculate this for every count, and after calculating this we will apply this formula, and we'll do the summation of the observed frequency, which are these observed frequencies, right? How we will get this? With the help of contingency table. We'll make the summation of the frequency, and we'll subtract from the expected frequency that we have calculated, right? Once we calculated the expected frequency, we will apply this formula. If the chi-square value is high, means there is a relationship between these two variables. If the chi-square is 0, means there is no relationship. When we get the highest value? When there is the difference is high between the observed frequency and the expected frequency. Obviously, if the expected frequency and the observed frequency, if there is a higher difference between them, it means that there is a relationship, right? So after calculating this chi-square, we will calculate the p-value. After calculating the p-value, if the p-value is greater than alpha, as I said that if the p-value, when we get the p-value, the p-value will be higher when the chi-square value is low, right? P-value will be very low if the chi-square test is very high. So if the p-value is greater than alpha, means there is no relationship, means we will support this null hypothesis. If the p-value is less than alpha, we will reject it and will accept the alternative hypothesis, right? This is how we use the chi-square test. So basically, the chi-square test is used to check the relationship between the two variables of the categorical variables, right? Here we follow the steps. We'll calculate the chi-square with the help of this contingency table. We calculate the expected frequency with the help of the sum of rows with the sum of columns divided by total, and with the help, once we calculate the expected frequency, we'll apply this formula. If the difference is very high, the chi-square value will be very high. If the chi-square value is very high, means there is a relationship between the two variables. If there is no difference between the expected frequency and the observed frequency, means the chi-square is 0. If the chi-square is 0, means there is no relationship between these two variables, right? It is very useful in research, in a data science.